Video is going to show you how to write a polynomial equation when you are given the roots. So the first thing that you want to do is write the polynomial in factored form. So if you know where the roots are, then you create the factors because they come from zero product property. If you are given an imaginary root, then you're going to need to multiply your factors through so that you can eliminate the I in your polynomial equation. This will come a little bit later on in the chapter. And then you need to solve for A, your stretch factor, if you are given a point that the polynomial goes through. So our first example, it says, write the equation of a polynomial with roots at 3, 5, and -1. Well, I would start by writing the factors. So if my polynomial has a root at 3, then its factor is x minus 3. If I have a root at 5, the factor is x minus 5. And if I have a root at -1, then the factor is x plus 1. Now you can just leave it like this. This is considered factored form, or you can multiply it through. So then I would do box or FOIL with like the first part, x minus 3 times x minus 5, and I get x squared minus 8x plus 15. And then I have to multiply that through with x plus 1. You can use the box method again. And then you end up simplifying and combining like terms to get x cubed minus 7x squared plus 7x plus 15. It is okay to leave your polynomial in factored form, but you can write it in standard form as well. Our next example says, write the equation of a polynomial that has a double root at 1, a root at -3, and it goes through the point 0, 9. Well, having a double root, remember, means that my factor is to the second power, so x minus 1 squared. My root at -3 is going to have a factor of x plus 3. And then what's different with this example is that I put my stretch factor out in front because I was given some other information about my polynomial. It goes through the point 0, 9. So I'm going to plug in the point 9 for y and 0 in for x, and then I want to solve for my stretch factor. So then I get 9 equals a times 1 minus 3, because 0 minus 1 is a -1, but square it becomes +1, and then 0 plus 3 is 3. And then to get a by itself, I need to divide both sides by 3. And so then I get a, my stretch factor is 3. And so now just plug that back into the factored form equation, and you get y equals 3 times x minus 1 squared times x plus 3. When you're given the graph and you need to write the equation, you got to look closely at where the roots are. And so I can see that my x-intercepts are at -3, -1, and 2. And at each of these points, my polynomial crosses the x-axis. There's no bouncing or nothing appearing like a cubic. So then I know my multiplicity is just going to be single roots. And so factored form is going to be y equals x plus 3 times x plus 1 times x minus 2. Remember to take the opposite of what your roots are. And then I put an a out in front because I can see another point on my polynomial. And this is just to make sure that I don't have I have a stretch factor other than 1. And so I'm going to plug in the point that I see, which is 0, 6. Plug in the 6 for y and the 0 for x. When I multiply that through, I get 3 times 1 times -2, which is -6. I'm going to divide both sides by -6, so I get my stretch factor to be -1. So all I did was flip my graph. I don't have a stretch that makes my graph skinnier or wider. So the final answer is y equals -x plus 3 times x plus 1 times x minus 2. And the last example that I have, this polynomial, you can see the roots are at -2, -1, and +3. But then look closely at this -1. You can see that the polynomial bounces off the x-axis. And so right here, it appears to be, a little bit looking like a parabola. And so that means I have a multiplicity of 2. And so I have y equals x plus 2 times x plus 1 squared because of that double root, and then x minus 3. So I can see my other point that my polynomial goes through is 0, 3. So I'm going to plug in the 3 for y and the 0 for x. This comes out to be 2 times 1 times -3, which is -6. So when I divide both sides by -6, I get a stretch factor of -1/2. And so my final answer, y equals -1/2 times x plus 2 times x plus 1 squared times x minus 3. Thank you for watching my video.